All right, so 6.2 talks about inconsistent dependent systems. It's the same thing we were doing in 6.1, but there's some special cases. So you look at example 1 here, and it tells us to use Gaussian elimination to solve the system. So we're going to start out just like what we did before. First thing we're going to do is we're going to write our augmented matrix. And so let's do that real quick. Okay, so we have that written out. Now remember, Gaussian elimination is just where I need the ones on the diagonal and zeros underneath it. It's the Gauss-Jordan that I have to have all the numbers be zeros except the ones in the diagonal. So, remember our first thing is we need to make this a 1. And it already is, so don't mess with it. Don't touch it at all. So then my next thing is I need a 0 below it. So how can I make this number here, this 2, become a 0? Well, what if I took, to make that a 0, I need a -2. So if I take row 1 and I multiply it by -2, and then I add row 2 to it, that should give me what I need right there. So let's do that. So let's see. I am going all the way to the bottom on this one, so I'll have to do the work on the side over there. So I'm replacing row 2, which means I'm not going to change row 1 or row 3. So let's go ahead and let's write those down. Now, of course, the better you get at doing this, you can do more steps in one thing. We might have been able to work on row 2 and row 3 at the same time, but for now, let's just do one thing at a time because we don't want to make a silly mistake because we're doing too much work at once. All right, so for the first column there, we said it's going to be -2 times row 1, so it's going to be -2 times 1, and we add that to the row 2 in that same column, so +2. So -2 plus 2 is 0, and that's what we wanted. So then for column 2, it was the -2 times row 1, which is -2, plus the original row 2. So we got 4 minus 3, which is 1. And then for the third column there, sorry, just lost my train of thought, it's -2 times row 1, which is -1, plus the original row 2 there, which is -1. So work that out. We get 2 minus 1, which is 1. And for that last column there, same thing. It's -2 times the row 1 plus the original row 2 of 0. So we get -10 plus 0, which is -10. I didn't put 1 there, so if you wanted to, you could. So this is -10. Okay, continuing on. Now we need to get a 0 right here in that very first column, third row there. Instead of the 3, we want a 0 there. So what can I do to make that 3 disappear? Well, I need to combine it with a -3. So let's take, for our third step here, let's take -3 times row 1, and let's add row 3 to it to get our new row 3. So just like I've been doing, since I'm replacing row 3, I'm not messing with row 1 or row 2, so I'm just going to rewrite them. Alright, so working this out, so at -3 times row 1, which is 1, plus row 3, which is 3, so -3 plus 3 is 0. For the second column, I'm just going to write it below here. It's -3 times row 1, which is -2, plus row 3, which is -4. So we get, what's that, 6 minus 4, which is 2. For the third column there, it's -3 times the number there in row 1, plus what was there from row 3 before, -1. So you get 3 minus 1, which is 2. And for the last column there, it's -3 times what's in row 1, the 5, plus what was originally there, the 1. So it's -15 plus 1, which is -14. Okay, so continuing on. Now we're going to look for a 0 right there. Well, what can I do that would give me that 0? Well, but now remember, we don't want the 0 in front to change, so I need something that has a 0 in the first column as well, so that we don't change the 0 to the left of that 2 we're trying to change. So I'm going to have to use row 2. So I need to make that 1 that's in row 2 a negative 2. So I'm going to multiply negative 2 times row 2, and I'm going to add that to row 3 to get my new row 3. So again, we're changing row 3, so row 1 and 2 are going to stay the same, so I'm going to rewrite them. Alright, so negative 2 times my number from row 2, which is 0, plus what I had in row 3, which is 0, so 0 plus 0 is 0. I'm going to write below it this time. Again, so it's negative 2 times the negative 2 from row, oops, hold on, nope, I'm just kidding. We're using row 2 and I accidentally grabbed the number from row 1. So let me start over on this one. So for the second number there in the second column, it's going to be negative 2 times the number in row 2, which is a 1, plus the number we originally had in row 3, which is 2. So negative 2 plus 2 is 0. And that's what we wanted there, remember? Alright, so then we got negative 2 times the number that's in that column from row 2, which is 1, plus the number that was originally there, which is 2. So we got negative 2 plus 2, which is 0. That looks odd, all zeros. That means something special is going to happen, depending on this last number. Alright, so then for the last column there, we have negative 2 times the number from row 2, plus what we had previously in row 3. So it's what, 20 minus 14, which is 6. Alright, so what this is telling us is there's something funny going on. When you end up with 3 zeros in the row, you have two options. Either it's true for infinitely many solutions, or it's not true for any of them. So you got to think about this. If I wrote it out, this would say that 0x plus 0y plus 0z equals 6. Well, 0 times anything is 0, so 0 plus 0 plus 0 equals 6. And when you add those, you get 0 equals 6. Is that true? Of course it's not true. So since it's not true, that means this one has no solution.